We are still on applied mechanics for engineers, and we have another question. This is example 3. Okay, so this is it. This is a tower guy wire. It's like an MTN mast, a tower guy wire. That is what it's called. Okay, it's like an MTN mast, and then it is anchored by 3 cables: cable AB, cable AC, and cable AD. So let's get a clearer view of this diagram. Let's get a clearer view of the diagram. Okay, so this is it. A clearer view of the diagram. This is it. Alright. So let's get a clearer view. You see the Z axis over here, the X axis is there, and then the Y axis up there. Okay, that's point A, point B this way, point D, point O, the center point, and point C. To get a clearer view of the diagram. Okay, right, the dimensions are there: 4 meter, 12 meter, 13 meter, 6 meter, and 9 meter. Okay, all right. A transmission tower is held by 3 guy wires attached to a pin at A and anchored by bolts at B, C, and D. If the tension in wire AB is 250 kilonewton, determine the vertical force P exerted by the tower on the pin at A. Determine the vertical force P exerted by the tower on the pin at A. Alright, let's come back to that diagram. So they said it is anchored by bolts B. This is the bolt B, bolt C, and bolt D. Okay, and then these are the bolts B, C, and D. And we are told that the tension along cable AB, along cable AB, as AB, this tension along this wire is 250 kilonewton. 250 kilonewton. Now we have to determine the vertical force exerted on the tower at P. So there is a force acting at point A. At this pin here, the pin at point A, there is a force. We can take this force upwards or downwards as we choose. There is a force acting at point A. Now let's look at the free body diagram quickly. Let's look at the free body diagram. Okay, so this is the free body diagram. Let's take a close look at the free body diagram. This is it. This is my free body diagram. Okay, that's the free body diagram over there. Alright, this is the free body diagram. And this is point A. Okay, point B, center point O, point C, and point D. Okay, the coordinates are I, J, and K. Alright, these are the dimensions. Dimensions are there. So that's the free body diagram. It has been simplified. Now we can then solve it. You have vector TAD and the unit vector, vector TAC and its unit vector lambda AC, vector TAB and the unit vector lambda AB. Now the force acting at point A is P. I took it an upward force acting at point A, that's P. Alright. Okay, now let's solve that question. This is the free body diagram. Okay, let's go. So you see, consider the resultant. Take the resultant of all the forces. Take the resultant of all the forces. So this now will be arrow equals to sigma F, which is equal to the first force there is TAB, the next is TAD, and next is TAC, and finally you have force P. Okay, so this is TAB, tension TAB plus tension force TAC plus tension force TAD plus the vector P. Okay, so I call that a vector until I've done the proper resolution of the forces. So that's the vector TAB, vector TAD, vector TAC, and vector force P. Right, which I can call this equation 1. That's the summation of all the forces, taking the resultant of all forces. Then I'll consider cable AB. So if I consider cable AB, look for the position vector AB. Position vector AB, RAB will be, okay, observe the coordinates I, J, K. If you are going like this, it's positive I. If you are going up, it's positive J. If you are coming this way, it's positive K. So if you are going opposite, it's like this, negative K. If you are coming down, negative J. Then if you are going like this, it's negative I. Take note. Okay, let's move from point A to point B. Now, if I move down from here now, I'll move down to this point. I'll move down like this to here. I'll stop. That is minus 18J. So I come down like this, minus 18J. I'll move like this. Minus like this, minus 9I. Finally, I come like this, plus 6K, because of this 6. Come like this, plus 6K. Okay, let's move again. Come down, minus 18J. I go like this, minus 9I. Come like this, plus 6K. Okay, let's go again. Minus 18G, like this, minus 9I, and come like this, plus 6, because of this direction of K, plus 6K. Okay, so that is it. So I'll be having minus 18G, coming downwards. Then the next thing I did was to take this other direction, opposite I, which is minus 9I, and finally come down here to point B, plus 6K. Okay, that is it. At this point, you come down to point B here, 6, and this is K, plus 6K. Alright, so arranging it properly, now I have RAB is equal to, this now will be minus 9I, minus 18G, plus 6K. So this is the position vector. Now find the unit vector RAB, the modulus of the vector. The modulus of the vector will be square root of minus 9 raised to the power of 2 plus minus 18 raised to the power of 2 plus 6 raised to the power of 2. Okay, so that is using Pythagoras rule. And then I'll be having modulus vector RAB equals to square root of 9 squared is 81. 18 squared will give me 324 plus 36. So if I add them now, I'll be having square root of, adding that I'll have, if I add this now, I'm having 441. Okay, when I find the square root, I'll have 21. Okay, so that is the magnitude or the modulus. Modulus is 21. Now the unit vector lambda AB, unit vector will be equals to the position vector divided by the modulus. So that will give me, so unit vector lambda AB will be equal to the position vector. Take down this value. It's minus 9I minus 18J plus 6K. Okay, divided by modulus is 21. So that means that lambda AB equals to minus 9 divided by 21 I minus 18 divided by 21 J plus 6 divided by 21 K. Okay, so I have lambda AB as minus 9 divided by 21 will give me, okay, so if I divide this by this now, I have minus 0.428 I. Then divide this other two, I'll be having 0.857J, and divide this to 0.285K. 0.285K. Alright. Okay, so that is it. Lambda AB is that. Alright. Alright, so the next thing I'll do is to find the vector TAB. Vector TAB is equals to the original tension force TAB times the unit vector lambda AB. Okay, that is the vector. This is showing that it's a vector. Vector TAB is equals to the original tension force times the unit vector. Okay, and let's come back to that question. I said, if the tension in wire AB is 250 kilonewton, so the tension acting along this wire, the original tension acting along wire AB is 250 kilonewton. Let's take that. Okay, say but tension force AB is 250 kilonewton. It's 250 kilonewton. So that means that the vector TAB is equals to 250 multiplied by, put the value of lambda AB there. Lambda AB now will be minus 0.428 I minus 0.857 J plus 0.285 K. Right, so if I multiply this now, I have vector TAB will be equal to, this will multiply this, and I'll be having a negative value here. That will be, this will give me minus 107 I. This times this is negative, so I'll put my minus first. Then when I multiply, I'll have that is minus 214.25 J. Then this will multiply this. This is positive, so if I multiply 250 by this other one, I'll have I'll be having, so this will give me 71.25 K. Okay, of which I can call this one equation 2. Alright, so this is it. 107 I minus 204.25 J plus 71.25 K. That's equation 2. Okay, recall that this is equation 1. Right, now let's consider the next cable, which is cable AC. Consider cable AC. Cable AC. Let's consider that quickly. So consider cable AC. It means that RAC now will be equal to, quickly let's do that. Okay, now let's move from point A to C. If I move downwards like this, that is minus 18J. If I move like this, from here now move like this, that is plus 13K, and I come like this, plus 6I. Okay, this is 6. This is 6. Okay, so let's move again. Let's move down again. I come down. This is the value, the distance there, 18. So let's move, come down. I have what? Minus 18G. I move like this. This is 13. I move like this. Plus 13K with K direction. Plus 13K. And I move straight like this to point C. Plus 6I. 6I. I is coming like this, so it's going this way too. Plus 6I. Okay. So take note. I come down. 18, sorry, minus is coming down. Minus 18G. Go like this. Plus 13K. Move like this. Plus 6I. Okay. Alright. Okay, so RAC now will be minus 18G plus 13K plus 6I. Okay, that was what I had from the free body diagram. It's minus 18J plus 13K plus 6I. So that means that if I arrange it properly now, RAC will be equals to 6I 6i minus 18j plus 13k as with respect to ij and the k coordinates. So it then means that the modulus RAC, modulus vector RAC will be equals to square root of 6 square plus minus 18 all raised to the power of 2 plus 13 all raised to the power of 2 is equals to square root of 6 square is 36. 18 raised to the power 2 will give me, so 18 square will give me 324 plus 169. So if I add them now, I'll be having square root of adding this will give me, this is 529. Finding the square root of the answer, find the square root, I'll have the modulus vector. Square root of that will give me 23. Now I've gotten that, my modulus vector is 23. Now I'll say the unit vector lambda AC, and the AC is equals to position vector RAC divided by the modulus RAC is equals to, if I take the whole of this out, take the position vector out, I have 6i minus 18j plus 13k divided by 23. Okay, so lambda AC is equals to, if I separate them now, splitting them out, 6 divided by 23, I minus 18 divided by 23j plus 13 divided by 23. Okay. If I divide this now, I have lambda AC equals to 6 divided by 23 will give me 0.261i minus, if I divide this now, 18 divided by 23 will give me, which will give me 0.783j plus, divide the other one, I'll have this now give me 0.565k. So this is it. This is what I'm having. That's 0.261i minus 0.783j plus 0.565k. When I divide them, I'll have this. Okay. So the vector TAC will be equals to TAC lambda AC. So vector for TAC will be TAC times, put the value of lambda AC. Lambda AC now is 0.261i minus 0.783j plus 0.565k. Okay. Alright. If I multiply it now, this will give me vector TAC is equals to 0.261 TAC I minus 0.783 TAC J plus 0.565 TAC K. So this will give me equation 3. Okay, that's equation 3. Now the next thing I'll look at, I'll consider cable AD. Consider cable AD. Consider cable AD. Consider cable AD, and I'll have okay, now let's consider cable AD. If I move down from here, to this point, let's move from here like this. This is minus 18j. Then I move like this. If I move like this, it is minus 12k. Remember, this is the distance. So from here now, I move like this, minus 12k. Finally, I come down to this place. I move down to this place. That is plus 4i. From here, come down like this, 4i. So let's come down from here. If I come down like this, I'll have minus 18g. Minus 18g. Then this is to go like this. If I go like this, that's minus 12k plus 4i. Take note. Come down. If it's going up, it's plus j. If I come down like this, it's minus 18g. That is with respect to this, from point A to come down, minus 18g. To go like this. From here to move to this point. That is with respect to this distance. So coming like this is plus k. Going like this will be minus 12k. Then to come down to this point, plus 4i. No, this is I. So go like this, plus 4i. That's what I'm having. Okay. So RAD will be, you have minus 18g. Minus 18g. Then when we came down, we had minus 18g. Then we had to move like this. Moving like this, we had minus, going like this, we had minus 12k. Minus 12k. Then finally we came down. Came down like this, that is with respect to I, plus 4i. Plus 4i. So arranging it properly now, have 4i minus 18g minus 12k. Okay, this is RAD. Alright. Now the modulus of that vector RAD, modulus RAD will be square root of 4 square plus minus 18 square plus minus 12 square. Okay, so RAD will be square root of 4 square is 16 plus 18 square will give me 324 plus 12 square is 144. If I add them now, I have okay, so this will give me square root of 484, and the square root of 484 is 22. Okay, that is RAD modulus. The modulus of RAD is 22. So lambda AD, which is the unit vector, will be RAD over the modulus RAD. So now will be equals to that is 4i minus 18j minus 12k divided by 22. So when I split them now, I have lambda AD equal to 4 divided by 22 I minus 18 divided by 22 j minus 12 divided by 22 k. So that lambda AD will be equal to, if I divide that, I'll have so this will give me 0.182 I minus, if I divide this other one, I'll be having 0.818 j. If I divide this other two, I'll be having 0.545 k. Alright, so that is it. So then I'll look for the vector TAB, vector force TAB equals to original TAD, original tension force TAD times the unit vector lambda AD. Okay, so that is it. Now substitute all these values inside here, and I'll be having, so the vector force TAD will be equals to TAD multiplied by, I put the values, that's 0.182 I minus 0.818 J minus 0.545 K. Okay, so that's it. I will then expand it by expansion. Now this will times this. I have 0.182 TAD I. So times this, I have minus 0.818 TAD J. This will times this one, I have minus 0.545 TAD K. Okay, that will give me, call this one equation 4. Call that equation 4. Okay, I'll come back to the free body diagram, and I'll have I'm having a force acting at point A. The force is going upwards as a vertical force P at point A. So since it's going upwards now, to be plus, that's positive. That's positive PJ. Positive PJ. So that will be, so consider the vertical force P exerted by the tower at point P, at pin A rather. So consider the vertical force P exerted by the tower at pin A. So that means that the vector P will be equals to, since it is going upwards, that is plus PJ. Okay, plus PJ, which I can call equation 5, plus PJ. Okay, but supposing this force were to be acting downwards, it will be minus PJ. Take note. Supposing we are acting downwards, it will be minus PJ, but since it is upwards, it is plus PJ. All right. Now say substitute equations 2, 3, 4, 5 into equation 1. So equation 1 now we change to, that is R equals to sigma F will be equal to first put equation 2. No, equation 1 first of all was tension AB plus tension AC plus tension AD plus the force P. So this now we change to sigma F equal to, if I substitute the values, I'll be having, that is minus 107 minus 214.25 J plus 71.25 K. So I put that of TAC, that is that's equation 3. Okay, I put it there. Out of TAC is 0.261 TACI minus 0.783 TACJ. And I continue. This is plus 0.565 TACK. And I put that of TAD as this other one, equation 4. I'll put it there. So I have 0.182 TADI minus 0.818 TADJ minus 0.545 TADK. Okay, plus P subscript J. Alright. Okay, so that is it. This is what I'm having. And I substitute the values. This is what I'll have. Then I'll take all the I coordinates. I coordinates. I'll take all of them. So that's how we're having sigma F equals to minus 107. And I take the next one. Plus 0.261 TAC. I take the next one. Plus 0.182 TADI. Alright. Then I take all the J coordinates. J, and J. So taking all the J coordinates now, I have minus 214.25 plus, okay, sorry, this is negative. It's negative. That's minus 0.783 TAC. And the next one is minus 0.818 TAD plus PJ. Then take the K coordinates. This is 71.25, which is K. Take the next K, which is this one, plus 0.565 TAC. And take the next K coordinate, which is this, minus 0.545 TAD. Okay, this is K, coordinate K. Okay, so these are the coordinates I, J, and K. Alright, so this is equivalent to saying that summation of forces will be equals to sigma Fx I plus sigma Fyj plus sigma Fz K. Okay, so if I compare coefficients now, sigma Fx is the whole of this. This is I. This is I. Sigma Fy is the whole of this. This is J. And this is J. And that sigma Fz is this one. This is K. This is K. Okay, so observe it. So that is it. So I'll be having sigma Fx equal to minus 107 plus 0.261 TAC plus 0.182 TAD. Okay, don't call it an equation yet. Leave it. Then this is sigma Fy equals to minus 214.25 minus 0.783 TAC minus 0.818 TAD plus what? Plus P. Okay. Alright. So sigma Fz will be equal to 71.25 plus 0.565 TAC minus 0.545 TAD. Okay, so that is it. This is it. The whole of these values is sigma Fz respect to K. This one is sigma Fy respect to J. This one is sigma Fx with respect to I coordinates. Okay, so I'll say equilibrium conditions equilibrium conditions. For equilibrium conditions, sigma fx is equals to 0, sigma fy is equals to 0, and sigma fz is equals to 0. Okay, those are static equilibrium conditions. I can then go back to that of sigma fx. That sigma fx, if sigma fs is 0, I'll be having minus 107 plus 0.261 TAC plus 0.182 TAD is equals to 0, of which I can call this one equation 6. So this equation 6, then sigma fy will be equals to 0. Then applying that now, I'm having minus 214.25 minus 0.783 TAC minus 0.818 TAD plus P is equals to 0, which I can call this one equation 7. Okay, so take note, that's equation 7. Minus 214.25 minus 0.783 TAC minus 0.818 TAD plus P equal to 0. And I can then apply the equilibrium conditions to sigma fz. So if sigma fz is equals to 0, this equation now will change to 71.25 plus 0.565 TAC minus 0.545 TAD is equivalent to 0. I can call this one equation 8. Alright, so this is what I'm having for now. So I'll say from equation 6, equation 6 is minus 107 plus 0.261 TAC plus 0.182 TAD equals to 0. So if I make TAD the subject of formula now, if I carry this one over here, take this over here, I have 0.182 TAD equal to, take this over here, this is 107. Carry this one over to this place, will be minus 0.261 TAC. And divide by the coefficient of TAD, that is TAD will be equals to 107 minus 0.261 TAC divided by 0.182. So the tension TAD will be equals to if I divide this by this, that's 107 divided by 0.182 minus 0.261 divided by 0.182 TAC. Okay, so tension AD will be equals to, divide this now, I have, so this will give me 587.9 minus, which is 1.434 TAC. I can call this one equation 9. Okay, I say substitute equation 9 into equation 8. Substitute 9 into 8. I substitute 9 into 8 now. Anyway I see TAD, I'll write the whole of this. So I'll write out equation 8. Equation 8 is 71.25 plus 0.565 TAC minus 0.545 TAD equals to 0. So in place of this TAD, I'll write the whole of this. Write the whole of this in place of TAD. That's the mean of substitution. So I'll be having, so now I'll be having 71.25 plus 0.565 TAC minus 0.545 open bracket 587.9 minus 1.434 TAC close the bracket is equivalent to 0. Alright, so this now will be 71.25 plus 0.565 TAC minus this will times this, and I'll have this will give me 320.405 minus times minus is plus, this times this will give me this plus 0.782 TAC is equivalent to 0. Okay, so I'll take the TACs one side and take this other one. So I have 0.565 TAC plus 0.782 TAC plus 71.25 minus 320.405 is equivalent to 0. Okay, so add these two and then add this and tackle this other one. This is negative. So adding these two now, I'll be having so if I add this now, we're having 1.347 TAC and tackle this other two, I'll have it's minus 249.155 is equivalent to 0. Minus 249.155 equivalent to 0. So if I carry this one over here now, I have 1.347 tension AC equal to 249.155. It's equivalent to, sorry, as we cross over here, it's equivalent to this. Okay, so making TAC subject of formula now, TAC will be equals to 249.155 divided by, so I will divide by the coefficient. The coefficient of TAC is 1.347 divided by 1.347. So if I divide that now, dividing by 1.347, I'll have, so this will give me 184.97. 184.97 Newton, kilonewton rather, kilonewton. Okay, so it's 184.97 kilonewton. All right, then so I say substitute TAC equal to 184.97 kilonewton into equation 9. Equation 9. So equation 9 now will be TAD equals to 587.9 minus 1.434 TAC. So I'll put the value of TAC here. This is 587.9 minus 1.434 multiplied by 184.97. Okay, so this will give me 587.9 minus, this will times this, and I'll be having, I'll have to give me 265.25. Okay, so if I subtract them now, I'll be having so this will give me 322.65 kilonewton. That's tension in cable AD. Okay, 322.65 kilonewton. So I say substitute TAC equals to 184.97 kilonewton and TAD equals to 322.65 kilonewton into equation 7. substitute them into equation 7. Okay, so I'll write that equation 7. Equation 7 is minus 214.25 minus 0.783 TAC minus 0.818 TAD plus P is equals to 0. Okay, so if I put the values now, I'll be having minus 214.25 minus 0.783. The value of TAC is 184.97 minus 0.818. The value of TAD is 322.65 plus P is equivalent to 0. Okay, so this now will give me, this is minus 214.25 minus this times this will give us okay, so this will give me 144.83 minus this times this will give me, this will give me 263.93 plus P is equivalent to 0. Okay, that's 263.93 plus P equal to 0. Alright, so if I tackle everything now, I'll be having this will give me minus 623.01 plus force P is equals to 0. So if I make P subject of formula now, force P will be equals to, carry this one over here, is 623.01 Newton. Final answer. That's the final answer. Therefore, the force P is equal to 623.01 kilonewton. Right? That is it. 01 kilonewton. 01 kilonewton. That's the force P is 623.01 kilonewton. Okay, that is 623.01 kilonewton, and we couldn't have solved it until we got the tension in each of the cables. So we got the tension in cable AC as 184.97 kilonewton, and we also got the tension in cable AD as 322.65 kilonewton. Okay, so finally we got the force P as 623.01 kilonewton. Alright, so just observe it. We have come to the end of the question. Come to the end of the question. Observe. Okay. So observe everything we have done. Alright. So that is it. We did our substitution into equation 7. Then finally we arrived at this. 623.01 kilonewton. So therefore the force is 623.01 kilonewton. This was everything we solved. Everything that we solved. Everything is here. Calculating conditions. After that, okay. This was everything we did. And the free body diagram as well. That's the question. The free body diagram is this. FBD, very important. You must draw a free body diagram. With the aid of the free body diagram, then you can solve it. With the aid of the free body diagram, you then solve. Very important. Okay. Alright. Alright, we've come to the end of the lesson. This is physics made easy by Prosper Nodi. Specifically, this is on applied mechanics for engineers. Applied mechanics for engineers. So please do it to like the video. Also share the video with your friends, those who will need it. Applied mechanics for engineers, those who are offering such courses, share it with them, and also subscribe to my channel. Thank you. God bless you. We'll be stopping here for today. God bless you. Thank you.